Good evening. How's everybody doing? Say hello. All right, you hear me fine. Fantastic. My name's Don McCoy, and I'm the mayor of Fulshear, Texas. Whoop. Is it got a whoop? Is that like A&M? That's great. But Fulshear, the fastest growing affluent city in the United States, comes with a lot of its own challenges, but it's fun. I've enjoyed being the mayor, but I've also been the president of the Fulshear Chamber of Commerce for Fulshear Regional Chamber for Commerce is what we call it for the last, 12 years now. So it's been quite a fun time. I've seen Fulshear grow from 2,500 residents. We're pushing about 50,000 right now. And we're building an artery that's going to dump everybody right there. And I think a few people out here are looking for a home. So I'm also a realtor. No. I'm not. I am not a realtor. But it's really awesome to be invited by John and all the team at TerraFlow Energy to be your MC this evening. I think you guys are in for a wonderful amount of information, things that will make you go, well, how neat is that? And I'll start right now. So you guys just go ahead and when y'all get a chance, come and take your seats. But today we gather is to celebrate ideas, to do more than power homes and businesses. It's also to power possibility. Here in this great nation of ours, the United States of America, the spark of an idea can ignite an industry. A dream scribbled on a piece of paper can become a company that changes the world. How many have done that and scribbled an idea on a piece of paper? I think that's how Southwest Airlines got its start. Yeah. But creativity and innovation are often celebrated with insightful quotes. And a popular theme is that creativity is limitless and it fuels further creativity. While innovation is about putting those ideas more into action. I'm going to quote Miss Levitt, Theodore Levitt. She said, creativity is thinking up new things. Innovation is doing new things. These truths remind us that the imagination and the courage in the face of failure and the willingness to challenge the status quo are the engines that drive progress. Anybody familiar with Thomas Sowell? Thank you. One. Good. Look him up. He offered a very profound perspective, and I've carried this with me all my life. The cavemen had the same natural resources at their disposal as we have today. And the difference between their standard of living and ours is the difference between the knowledge they could bring to bear on those resources and the knowledge used today. He emphasized that economic vitality, prosperity, human fulfillment flourish when individuals have the freedom to invent, create, and share in the rewards for their efforts. In a free market system like we have here in the United States, that personal stake in success becomes a powerful motivator for innovation. Ultimately, Sowell's view reminds us that the advancement of society depends on the fostering environments where human creativity is encouraged, valued, and unleashed. At the heart of TerraFlow Energy Innovation Showcase is this very spirit, where innovators, visionaries, and problem solvers come together. And it's been awesome to see all of you guys talking to one another, networking, exchanging cards, because most of you are here because you're all about innovative ideas. And you get to see challenges not as obstacles, but as an invitation to think bigger, reach higher, and lead boldly. This gathering is more than an event. It's proof that when creativity meets freedom, the results can light a path to a brighter, cleaner, and more sustainable future for us all. TerraFlow Energy is a homegrown Texas company building what's next in energy right here in our home backyard. Tonight is about bold technology, powerful partnerships, and the real projects already underway. You're going to hear from some of the most forward-thinking leaders in energy, technology, and policy. And we see firsthand how we're shaping the future of energy infrastructure. Now, to get us started, please join me in welcoming TerraFlow's founder and CEO, John Perella. John? Hello, John.
Thank you. I want to thank everyone for coming tonight. What we've been able to accomplish in about a year's time is nothing short of a miracle. In fact, if you look at the time that we actually were able to bring first dollar of capital in equity investment, it's been less than a year that we've gotten to this point. Tonight, we're going to walk you through an introduction to some of our partners that are helping us to get there. We're also going to walk you through the milestones we've reached so far and where we're going. And I think you're going to see very quickly what we're trying to do is really to stand up domestic-based manufacturing here in the United States. We're one of the few companies that are actually qualify for almost 100% domestic content to be able to provide a solution that's way outside the box of any other thinking. I was having an interesting conversation at lunch today with one of our partners, and if you look at a lot of the other battery companies that are out there, it's usually a bunch of PhDs that understand the technology very well, and they're the smartest people in the room, but they have no idea of how to think themselves out of a box. And so when they do things, they raise a bunch of money, and they're constantly in R&D, and they're constantly prototyping, and they never get to commercial scale. What's been interesting is the friendships we've created, the partnerships we've created, the people that I've been able to bring on to the team to help me to accomplish these goals, the investors we've been able to bring in. They're not just investors, every one of them is strategic, and they're all rowing in the same direction with us. So what you're going to see tonight, and if you saw it in the lobby, that's baby. That's our sandbox. That's just for testing stacks. What we're building is much, much bigger than that. And unfortunately, to accomplish some of these things, not every battery is alike. Okay? The batteries we're making are not small. They're not portable. They're very, very big. But what they can do is something that no other battery can do. So we're going to walk you through a deep dive of the technology tonight. We're going to introduce you to our partners and let them talk about why we're different, how we're different, how we're going to get there. It's nothing short of a massive mountain we've got to move to get there. But this room is filled with a bunch of our partners and people that want to do projects with us and to start educating the market about what we're doing so that it can move faster. The biggest difference that we're now trying to help with is how do we create grid resiliency but also allow AI data centers to function. There's a race to build AI data centers. Some of the people in this room are the ones building them. The problem is that they're racing, and they're all in a race to get there without thinking through necessarily how the power is going to be solved. Everybody's turning to storage to solve the problem, but not all of them know the best solution out there. So we actually have quite a few very large announcements we're going to be making today. We're very proud of everything we've accomplished. If you see somebody with a TerraFlow logo, they're more than likely part of the team or part of the family that's helped us to get here. And we want to share that with everybody in the room today so that we can start to educate the marketplace that we are here, we're standing it up, we're doing it big, we're commercializing it quickly, and we're going to accomplish some pretty impressive feats. I'm going to turn this back over to Mr. McCoy to be able to introduce our keynote speaker today. We really appreciate it. I'll join you guys a little bit later. Some of our team members will get up here to explain more in depth about the technology, but we really do thoroughly appreciate everybody that's here. I know a lot of people have traveled from all over the world, and we're looking forward to seeing everybody's reaction when we're all said and done.
But very amazing stuff, very exciting things we're going to learn today, and it's only the beginning of what we're going to learn about today. It's my pleasure now to introduce our very special guest. He has been a strong voice for American-led innovation, a champion for energy and independence, and an advocate for policies that strengthen our critical infrastructure. Please join me in welcoming Congressman Dan Crenshaw.
How y'all doing? Great to be here. I just got a great meeting with the TerraFlow folks and got a better understanding of how cool and interesting this technology is. One thing that stood out was everybody's a competitor in a way, but there's every once in a while there's a technology that comes along where they don't really make a lot of enemies. And so I can see how there's a broad swath of the energy sector here in this room today. Makes a lot of sense. You have a technology like this, very impressive. I've not learned a lot about it before today. And it's really what you need. Look, if you know my politics and my policy, I've been working on energy and environment issues for my entire time in Congress. And look, I want all of the above energy. I really do. But, I've also come from an oil and gas family. I grew up in Katy, not too far from here. And we moved all over the world, and, oil and gas is near and dear to my heart. And also, there's another thing about it is that it works. And, intermittent energy is a rough one. Wind's not always blowing, the sun is not always shining. If I can pretty much guarantee the sun will not shine at a certain time of day. And if that does not become true, then you've got like cosmic problems that have occurred. The solution has always been how do you store this? How do you make this a more viable solution? And then there's another problem, and that's been a question we've been trying to solve for a long time, and that gets to grid reliability. Something we were obviously very concerned with, or the big Texas freeze just a few years ago, and we were caught off guard. We have a lot of intermittent energy in Texas, despite being kind of the energy oil capital of the world. I mean, 30% of our capacity is wind. That could drop to zero, like it did, and a few other problems occurred. And next thing you know, everybody's in a blackout, and when it's 7 degrees outside. So that's always been a conversation, and you need this kind of new and innovative technology that's not made in China, and you need it here. So it's really awesome to see TerraFlow doing this, and I was really happy to hear that. And then there's the data center conversation. So for years, I've always cited a statistic that by 2050, energy demand globally will increase 50%. And I think that is wildly off now, because that's an old statistic, maybe a couple years old, because in the last couple of years, we've realized that AI, the need for data centers, is going to be a massive demand increase for energy. And I think that's why the Texas legislature recently passed SB 6, which requires baseload energy to be at that data center. So it looks like TerraFlow came in at just the right time. And these are things we need. And we need them here in the United States. We need the critical minerals that we need from them. We need them from friendly countries in the Americas, which I've learned is also where they get their critical minerals. I asked that question as well. Vanadium, I think. Sounds like something Wolverine has. Better to mine in Peru and Brazil than the Congo, and then have it processed through China. That's not what we want. So this is the kind of innovation that makes all of our industries stronger. Whether it sounds like it's nuclear, whether it's gas, it makes all of them stronger while also making our grid more resilient. So it's kind of American innovation that makes it easier on policymakers, because we don't want to be the ones to actually solve the problem, and you don't want us to be the ones to try and solve the problem, because inevitably we're not really solving problems in government. We are making trade-offs. You have to understand that about policymaking. The better solution is always, and I don't care what industry it is always innovation, and that's eventually what saves us. And our job, as I see it, is generally to make sure that there's an environment where that innovation can occur. I think now, over the next 4 years, I'm very excited about exactly that. Very much a pro-energy, an anti-over-regulation mindset that allows innovation to prosper. We've gotten some of it done just this year. We're looking at what the EPA is doing, reversing a lot of, I think, very misguided policies that have just constrained, especially a lot of Houston-based industry. That's something we cannot let happen and don't want to let happen. And then we're in full reversal over the next 4 years. So I think this is a great time to be in the energy sector. It's a great time to be a Houstonian and a Texan, and couldn't be prouder to be here and speak to y'all. So thank you.
Thank you very much, Congressman. It's great to have you here with us today and be a big supporter of what we're doing. I'm an oil brat as well, growing up overseas, so I understand energy needs. I also know that there's a little known fact that, speaking of innovation, how many people know that the weed eater was invented in Houston, Texas? Yeah, you knew that? Here's something you didn't know. The man who gave the inventor $4,000 for a prototype was from Fulshire, Texas. Just want to let you know, we still have weeds. As mayor, we're trying to mitigate that. But thank you, Congressman Crenshaw. Your leadership is reminding us of how critical it is to keep American innovation at the forefront of our energy future, and no one innovates like the United States. And speaking of innovation policy, and create the runway, but technology is the plane that takes off. The solutions we are talking about tonight aren't concepts on paper. They're real operating systems built right here in Texas, designed to meet the most demanding power challenges head on. Now, to give us a high-level look at the technology that makes TerraFlow's vision possible, please welcome the person who has been engineering from the ground up, TerraFlow's co-founder and Chief Technology Officer, Ian Rock. Ian?
You know, it's great. It's one of those things when people talk about bringing somebody into a scenario like this and they talk with a foreign accent, you're automatically an expert. Because why bring in somebody without a foreign accent if they're not at least an expert? And I have to say, this whole weed eater thing, it's just as well we still have weeds, or we wouldn't need weed eaters. So, people have spoken so far, many stories and horror stories that we have in Texas, and we've recently had the same. We've got somebody, actually we have an Irishman from Portugal in the room tonight. I don't know if any of you heard, recently Spain and Portugal, major parts blacked out because of energy problems. Gone are the days when you built a building, built a large load building, got your local electricity company to come along, put a pole up and you plugged in and everything just worked. We're way beyond that now. Grid is far less stable because we stress it so hard, and we have to do something to resolve the issues that energy has. Grown recently into popular truth are what we now call large energy campuses. We've got clean energy campuses. And when you get into the state, what we're basically saying is we're going to provide this area, and this area is going to take huge amounts of power, and we bring in infrastructure, and we have to make the provision of power from the grid, the provision of power from backup generation, the provision of power from batteries and helping grid resiliency, and we have to orchestrate all this. We're looking at one of those areas where we're creating, in the most simplistic form that we can, an orchestration of energy that benefits the grid and the generator and the consumer, the large load that's going to use that power. So they asked me to stand up here tonight and give you a high school chemistry lesson. We're going to do some chemistry and physics here. Actually, I'm not going to tell you about it. We're not going to walk through. This is a drawing of a flow battery. Anybody who wants to look it up, you'll find a version of exactly this anywhere you like on Google. It's common. What I do want to stand here and say, this is the technology around which TerraFlow is based, the redox flow battery. But what I also want to say is, although we are an innovative company, redox flow batteries are 30, 40 years old. It's not a new technology. And I want to emphasize, we're still an innovator, but we're using a very proven technology. It's been around for many, many years. We have someone from China in the room tonight. He works with one of the large Chinese companies. They have many gigawatts of flow battery in place today. They're doing it in a slightly different way. And we're looking at working with people to do it our way and a different way that we're going to do it here in the US. We're taking proven technology and applying it with an innovative slant and taking that to market. What we're doing is we're solutioning a market need. We're not developing a product and saying, here's my battery, please buy lots of them. We've gone out and we've found a market need. We've developed a solution and we're literally building a solution around the market need, physically building it around the need, around the client, and making something work for them. The cartoon I showed you, or the diagram I showed you before, this is a real-life image of what one of these flow battery stacks looks like. We're looking at building very, very large-scale implementations using many tens and hundreds of these. This thing that you're looking at, you've seen one downstairs. For those of you who came in through the lobby, there's a single unit downstairs which is for testing one of these. The black unit downstairs, the stack itself weighs about 500 pounds, so we're not really concerned that somebody's going to run off and steal it if we leave it in the lobby for a while. But this is what the fluid, the actual flow battery flows through, and what we use to charge and discharge that fluid. Today, most of the implementation that's done are people developing what's literally a product, and they're putting a number of these in a shipping container, and they're putting a number of tanks in shipping containers, and they're shipping many, many shipping containers to a site and putting them in concrete pads and trying to tie them all together and calling that a big battery. We're actually designing what is genuinely a big battery. This is a product that this is a site that was announced that went public recently. This is the actual. I've taken the building out of this image, but this is actually what will be inside the building up in Belleville, about 30-40 minutes northwest of here. And this is a 10 megawatt, 5-hour duration battery. So what you're seeing here are what we call a large tank format. This is a 4 200,000 gallon tanks of fluid, and 10 container-sized stacks, 8 container-sized stacks of the cells that generate power. And these are being built into a building and will do true grid energy support on a local basis over in Belleville. It's genuinely large scale. What's being solved here are two things. There are certain issues in creating large batteries where you mix the chemistry and electrical and you cross-contaminate power. You start losing efficiency. We've solved some problems here to enable us to go to these very, very large tanks. And we're not doing containers, we're doing it in a building. It's easy to maintain, it's easy to get around the system and control, manufacture, maintain. And this is the view that we're taking to market. So this is a battery. This one's about 25,000 square feet of buildings, and that's our starting point for what, as John tells you about some things later on, is essentially going to be our baby product. So this is one of the small systems. One of the main applications that we're looking at, and we're looking at this first off because it's easy to identify a number of needs, and for us to solution a number of needs, is the large-scale data center. The hyperscale data centers, the Googles, the Microsofts, the Amazons are all building massive, massive data centers. The new AI data centers are gigawatt, 2 gigawatt, 3 gigawatt, massive consumers of power. And I'll talk later why that's actually a good thing. It's not a bad thing. But they do come with problems. 3 problems mainly that they come with. They create distortion that goes back out onto the grid and causes damage to you personally, to business for machines, but to you at home for your washing machine, for your tumble dryer, anything with motors. It can actually start to cause damage if that issue is not handled. There's load volatility, I'll come to in a second, but these data centers can swing up and down. The AI data centers especially can cause large problems. Actually, if we look at it in this slide, this is a picture of a small data center load. This is literally one of the early AI data centers. It's about 160 megawatts, and the power's gone up and down 40 or 50%. So when you're talking on an AI data center, you're seeing hundreds of megawatts of power jumping up and down 10, 12, 14, 15 times a minute. You can't connect that to the grid without causing problems. You'll start tripping substations, tripping houses, subdivisions, towns. And that's issues which have to be managed. And And those are things which, with our systems and our solutions, we're putting in place large-scale capacity, which could handle all of the issues that may be brought to the grid, and solving those problems in an innovative way, but all with proven technology, bringing it all together. What we're doing, and the way we're doing things, as I said, we're not trying to develop a single product that we sell. This is a case that we're working on with some of the architects and some of our partners in the room here, where we're actually separating where the battery produces its power and the tanks where the battery stores its power, and we're literally wrapping the power solution around a data center at the very low voltage side, so not at the grid scale, but everywhere where the data center uses its power, we're putting a solution in place and managing that volatility and managing those frequencies and stopping them from going back out to the grid. If you like, it's taking your car, somebody actually said this to me earlier on, it's taking your car and it's separating the engine and the gas tank. The engine provides all the power, and you're seeing that in the battery stacks in the center selection from the gas tank, which you're seeing in the tank. So we can make the gas tank bigger. Now, we're not going to be running a test on one of these batteries. They're a bit too big for that. But the analogy of the car engine and the gas tank is true. We can go longer if we simply put a bigger tank in place. So that's something that we're doing. We're handling problems that are real and apparent today for true large load implementations here in Texas and across the rest of the US. This is something that clients are going to have to put in place if they want to get the power. They're not just going to call CenterPoint and say, hey, put up a pole, plug me in. They're going to have to resolve these issues if they want power provided. So it's kind of it's a solution, but it's a must-have for the customers, which is always a nice place to be in. But we have a kicker for them. One of the things that we'll do with the battery, there's a requirement across Texas, and there's a provision across Texas, and people are making money where you turn your power down August afternoons. Right now, that's the highest price of power in the day, I guarantee it. People don't necessarily want to be buying power at this time of day. This is a simple graph. I'm not going to explain too hard, but basically the purple line is a representation of a data center using power. The green line is the cost of power. So for most of the day, power's $20, $30, $40, $50 a megawatt, but 5 o'clock, 5:30 until 10 o'clock, 10:30. On a good summer day in August, it goes up to $200, $250. On the bad summer days in August that we've had, price goes up to $1,500 and $2,500. Putting a battery in place not only solves your problem you have in actually working with the grid, it will pay for itself. So you have to spend the money, you have to use the battery, but here's an alternate way to actually get your money back. So what we're doing is using proven technologies, great innovations from different industries, from the flow battery industry, from oil and gas for the large tank format, from electronics industries for inverter rectifier methodologies to make these into long duration, and providing a way to make money while doing it at the same time. So that's kind of where we're coming from. So as I said, we're doing this with overseas partners. We have people across the world, but we've also got some people in the room today, mainly all here US based. So I'm going to introduce you to some partners that we're working with. A couple of guys from the chemistry and stack industry. So I'll talk you through. And what we're going to do is they are going to talk for about 5 minutes, but I'm going to bring them up on the stage. We're not doing a panel session, but I'll bring them all up so we're not going back and forward. So if you guys can come up as I call you out. So first of all, I'll invite Eugene up, Eugene Burr, who's the CEO from Keynote Energy. Now, Eugene wouldn't give you a high school course in chemistry. He'd give you a postgraduate doctorate of some description. So, Eugene, if you want to grab the far side.
Thank you.
And Puneet, if you want to wander up, I'm afraid I can't see anything out there, so I don't know where you are in the room. So Puneet is from Siemens. Siemens, as you guys all know, is a very large, very broad company. I think we've got 3 or 4 different divisions of Siemens here. Puneet is from the battery group and is one of the leaders in the battery group at Siemens. Bobby, I don't know where Bobby is. Bobby Hunt is the general manager at pneumatics and hydraulics. They have been a huge assistance to us over the last 12 months, providing engineering backup, manufacturing backup. Here, Pneumatics and Hydraulics is a Katy-based company. They're a partner company of ours now, and Bobby's the general manager of the local Katy facility. And then Travis, there we go, Travis Torrey. Travis is going to have to duck the hardest to get in here, but Travis is from Storied Energy, and he'll talk through. Travis is my counterpart, the Chief Technology Officer at Story, and they're building some of the big black stack you saw earlier in, and they're also a chemical manufacturing company in the vanadium electrolyte space.
Well, good evening, everyone. Can you hear me? All right, fantastic. Thank you all so much for coming, and thank you very much to John and Ian for putting this event together. So, most of you probably haven't heard of Crenshaw Energy. We're a startup formed from spin-off from Harvard University. And, what we do is, just now Ian gave a little introduction to what's a flow battery, right? I like to think about it like a car. If you've got an engine, you've got a fuel tank, you've got an air intake. You combine the fuel and oxidizer, you get energy, right? So in a flow battery, the electrolyte is the vast majority of the cost. It's by far the largest cost component. What we have is a proven innovative electrolyte that's a quarter the cost of the incumbent, which works great. But the kicker is our electrolyte is made from petroleum aromatics. And today we have a pilot production line in the United States, and we are looking to, in fact, bring this to the Gulf Coast, in the Houston area, maybe further down. But because it's coming from these petroleum aromatics, it's actually got a very stable supply chain. You can source it completely in the United States. And the really nice thing is it's compatible with vanadium hardware. So, the incumbent technology I'm telling you about, I think that actually makes us natural allies. It's like, if I were to continue with the automobile analogy, I found a way to go and make gasoline for a quarter of the cost, right? So who doesn't want something like that? And what's really nice is that it works already, and it works in commercial hardware and can scale really fast. So we're proud to be here today. We're really happy to also be working with TerraFlow, because of the visionary leadership of Ian and John. They really see the value, right? The opportunity that's there for the taking, and not only that, we can make it all in the United States. We can use American assets. We can use American raw materials as well. And for me, it's all about scaling as quickly as possible, right? And it's a huge opportunity. It's there for the taking, and I have never seen anybody move as quickly as the TerraFlow team. They see, they see a really, really good opportunity, and so do we. And they are laser focused on delivering products that Americans can use. And everyone uses electricity, right? So they're totally focused on working with us and rowing in the same direction. And, we couldn't be happier to be working with them and to be one of their partners. I think they're the first movers in the United States to really do projects at a large scale, and it's a natural partner that is for us, which is located in Texas. But for us, right, also, why Texas? First thing, as I said, our company is about making chemicals, and we're actually based in California. But let me tell you, trying to make chemicals in California is a losing proposition, right? So we're all about making chemicals, and they're coming from oil and gas. We really want to use that oil and gas infrastructure and chemical manufacturing infrastructure. The second one is these large tanks, ours is actually reasonably compatible with the carbon steel used in these large tank farms everywhere. That's something that Texas has an abundance of, and we're also here because we're looking for a manufacturing site along the Gulf Coast, like I mentioned. And finally, Texas is, I think, the fastest growing energy storage market in the USA. Right, so the time is right for us, to work together with the team from TerraFlow and everyone else on the stage here. We're really excited about the future, and I think you should be too. So thank you very much.
So I'll just tell you a short funny story that before John gets a chance to do it. So Kima were actually the reason we're in the room today. And John's mother-in-law is a commissioner in one of the local emergency departments. And Kima were putting flyers out through a door to try and find a place to do a small test, local, public-private battery. So John's mother-in-law hands the flyer to John and says, "What's this?" So John read it and called me up and said, "Ian, what do you think?" And I got suckered into this at that point. So Kina's actually the reason that we are in the room today. Puneet, so Puneet, as I said, from Siemens Battery Division. If you...
Thank you, TerraFlow team, for having me, and I'm glad to be representing Siemens. It is very much possible that Siemens has a company that used to make big things, wind turbines and the other very, very big things. But perhaps you don't know what Siemens of today, it is a major technology provider in the world. In fact, anything that you have touched today, be it your cell phone, be it the car you drove, the energy that is powering this building, or the LED lights, or the mic, everything, it is very likely the way they are designed or manufactured, they have used Siemens technology. So what I'm representing today is the Siemens that is empowering all the industries in how they can innovate fast and take those innovations to the real world through the manufacturing. And that power of innovation, that's what I saw, and that hunger that I saw when the first time I met with Ian and the TerraFlow leadership team almost a year back in a dinner. And when I met them, the clarity of their vision, the robust technology and the partnership they have put together, it impressed me a lot. And I was clear that Siemens, we want to be part of their ambition. We wanted to empower and support at the pace that they want to go. What we are looking to do for TerraFlow is bring the technology to them so that they can innovate fast. We talked a lot about innovation. We talked about how it is very important to bring these solutions to market fast, make sure they are reliable, and make sure they can be produced here in Texas, in US at cost-effective way, so that we can go and be the world leader in this market. And that's what we have the ambition to do, working with TerraFlow team and the kind of solutions and technology we are bringing together. And before I end, I just want to share a story. So if anybody who knows about teams and how a high-functioning team should work, is Navy SEALs team. And in Navy SEALs, they do something called LRC, which is Leadership Reaction Challenge. What that is they bring people and they give them some 20 tasks, and within a limited amount of time they have to do that. And they have always seen three types of teams. Team one, where a lot of people come together, they have a lot of energy, they want to get things done, but they don't think it through. So what ends up happening is they have a lot of energy, but they start falling apart as those tasks go forward. Then there are other set of people who come and they think it through fully, but they don't have enough time left to complete all the tasks. And then there are winning teams. So when I stand here today, when I talk to John and Ian and TerraFlow team, and I look at the other partners, I think this is the team that's going to win and make sure that US is energy independent, and TerraFlow becomes the center of powering data centers and the AI revolution. I look forward to it.
So I'm going to introduce Bobby now. Bobby, as I say, is one of our local guys. Bobby runs the pneumatic and hydraulic office here in Katy. He's a member of the Katy EDC, and they'll have you as well. They have been, I'm going to call them fabulous hosts to TerraFlow over the most of the last 12 months, to be honest. Even recently, we had a big meeting where we brought a bunch of the Storian guys over from Georgia, but we hosted the entire thing in Bobby's facility just 5 minutes away from here. So I can really say that he showed great taste and hospitality for a guy from Louisiana.
Thanks, Ian. Good evening. My name is Bobby Hunt. I'm the general manager of Pneumatic and Hydraulic Company. I'm based here in Katy, Texas. Our company is 66 years old and ranges from Baton Rouge to Odessa. We have 13 locations. We have 4 different divisions of our company, and the reason I'm going to talk about them is to explain how we work together with TerraFlow. Pneumatic and Hydraulic was the company I run here. We specialize in pumps, valves, motors, cylinders, something you need quite a bit of in a flow battery. We have a power temp company that specializes in power distribution, also something very needed in batteries. We have a generator company. We do power generation, natural gas generators, so we're familiar with power generation and how to handle it. And we have a manufacturing automation company. About 3 years ago, I was tasked with starting a hydrogen company where we specialize in generating hydrogen, dispensing it, and compressing it for vehicles in the hydrogen world. And that's actually how I met John. We were sitting on the panel for the Katy EDC talking about new technologies coming to the Katy area. And we get off the stage and John comes up to me, he's like, you have pumps and valves? I need a bunch of pumps and valves. I was like, great, because I want to sell you a bunch of pumps and valves. So the more we talked about their technology and what the TerraFlow team was doing and their vision for the company, it just so happens that a year prior to that, we developed a flow battery for a small commercial company, so we had some expertise, some understanding of how a flow battery would work, and seeing how their team was developed and what they wanted to achieve, we wanted to partner up with them. So like Ian said, we partnered up. We started doing the R&D at our facility. We've had a couple of different events, having people over to go over, how the function of the battery itself and then what it could achieve. So after the first prototype, now we're into a megawatt scale, and I'm sure we're going to go through some of that. And I guess to continue with your car analogy, if you have the fuel and the engine, we're the fuel pump and the injectors, I guess, got the pumps and the valves in between. So I guess that will fit into that. And as everyone is talking, with the demand in AI and data centers and the need for grid resiliency, we believe what TerraFlow is putting together is going to be a very strong candidate for something that we can use in the future to build for Texas. And the fact that it's American-made, one to build in Texas, we're a huge supporter of that, and we're glad to be partners with the guys and continue success. Thanks.
So before I introduce the next guy, so Bobby's facility over in Katy is where we managed to introduce our first proven, from our perspective, the first time we actually energized a flow battery, which is the keynote chemistry. Somewhere in the room we have Keith, who's come over from Europe to be with us today. Keith provided the stacks for that. And then say Bobby's got that running there. The system we have downstairs is our second implementation, and that's going to have Travis's stack on there. The big black stack downstairs is that system. So let me introduce you to Travis Torrey. Travis is the CTO of Storian Energy. I'm not going to say where Storian comes from because maybe you're going to do that, but we're working very closely. Where Keno does chemistry and Voltarian, who did that other system, do the stacks. And Keno's working with both that company. Oh, here's Keith. So, Keith, let me just introduce you. I'm going to introduce Keith for a number of reasons. I'm actually not going to introduce him because Keith comes from that company. I will also say Keith is actually the president of the International Flow Battery Forum. So he's an important guy in flow batteries. He's also, you're president of Flow Battery Europe, but you're a major part of the International Flow Battery Forum, and he's coming over here in end of October, I guess, to Chicago, and we're kicking off Flow Battery North America. So it's a very big and growing opportunity. So welcome to Keith's. Keith's company, though, did build the 3 white stacks that are downstairs, and they're working with Kino. Travis is working with Kino on the alkaline technology, but I'm going to let Travis come up and talk a little bit more about Storian Energy.
Thank you, Ian. So I'm Travis Torrey. I'm with Storian Energy. I'm going to start off by telling you a little bit about where we came from and what it is we're trying to do. So we are a joint venture between Storian Energy and Largo. Largo is a mining company for vanadium. They've got a vanadium mine that produces some of the highest quality vanadium in the world at a pretty good rate. And Storian Energy is one of the largest battery manufacturers in the United States. They produce a substantial amount of the automotive vehicle batteries here in the U.S., and they do everything from garden tractors all the way up to nuclear submarines. They have about 11 manufacturing facilities and are experts in many different technologies when it comes to battery. So what kind of happened between the two companies is both Largo and Storian decided to get into flow batteries. When they did that, what they found was it takes a lot to make a flow battery. It's not just a cell like you get in a lot of other batteries. It's a cell, and then the application is appreciably different than many of the other batteries, and the application focus has got to be very different. This is one of the areas where we feel TerraFlow has had a significant advantage in the marketplace. They understand the application, they understand where it's supposed to go. So both Storian and Largo, as they fought with owning the entire supply chain, they looked at each other and they say, hey, you're good at mining, we're good at manufacturing. Why don't we take what we're good at and put those things together and take a step earlier into the supply chain? So as Storian, our focus is to provide components into the flow battery space, specifically stacks and vanadium electrolyte. Vanadium electrolyte and vanadium flow batteries is one of the oldest technologies in the flow battery space and the most proven. It's got reliable installations across the world, and that's the first area that we're developing. So as we seek to grow our manufacturing footprint, we're exceptionally excited to have a partner like TerraFlow and to be able to grow into this space together. We are working together, and we really love their philosophy of taking the advantages of a flow battery system and growing it and scaling it to the next level. We think with their focus on the application basis and their focus on growing cost efficiency through scaling, together we can start to grow and see this domestic supply chain actually go in the U.S. We think that this technology is ready, it's been developed, and it's time to see this grow to a larger space, and we're really excited to be here and do it with these guys. So,
Thanks, Travis.
So why we asked these guys to come up on stage, as Travis has just highlighted, we're in a game working together where vertical integration is a key component, but we're not trying to be one company vertically integrated. We're all trying to stay in our own lane, stay in an area where we have expertise and understanding and bringing things together, but keeping a very close strategic relationship to each other, mutual interdependability, and with Kino, with Storian, with Voltarian, Siemens, and with engineering company like P&H, that really is how we plan on going forward. So I'd like to thank you for attention with us talking to you. I hope technically we didn't bore you too much. And Mayor McCoy, if I can ask you to come back up and take over then. Thank you.
Oh, okay. Boy, anybody understand that a whole bunch? Because I kind of did. I thought it was pretty interesting that the thing I heard is a lot of it's being all of it, not only in the United States, but here in Texas. And I like that. Yeah, that's fantastic. makes us the greatest state in the union, I got to tell you. And also, I did realize that, speaking of all this battery talk, did you know that, how come there are no B batteries? Hey, think about that. Well, I think this is the future of B. This B the battery. How about that? I think you can go ahead and take that. You got A batteries, C batteries, D batteries, but this B the battery, I think. We're going to take care of that. Oh, come on, you don't have to clap. I pray people to clap at my jokes, and they're evidently not paid enough. Okay, next up we have our leadership in duration energy storage, and we're going to have some wonderful remarks from Anna J. Siefkin. Did I get the name right? I didn't get a chance to meet you, but I hope I pronounced your name correctly. So, Ms. Siefkin, could you please come on up?
Thank you, Mayor McCoy, for that hilarious introduction. And thank you to TerraFlow and everyone here today for the opportunity to be a part of this exciting moment. Because we're standing, as many have already talked about, at the intersection of two of the most transformative forces in our economy today. So the rise of AI and the reinvention of our energy system. So what's unfolding here in Texas, and I am a visitor in Texas today, is more than a technical milestone, but it's a signal to the world that bold, integrated solutions are not only possible, but they are already underway and ready to go. So I'm the North America Policy and Markets Lead for the Long Duration Energy Storage, or LDES Council, and I have the privilege of working with leaders day in and day out across the globe who share a common goal to accelerate the decarbonization of our energy system through the deployment of long-duration energy storage, 8 hours and more, at speed and scale. So here's the key. So LDES, technologies that store not just hours, but for days and even weeks, aren't just helpful additions to the grid. They're foundational to what comes next. So because our future power system must do more than keep the lights on, we heard that already. It must absorb growing amounts of renewable energy, shift that power to when it's needed most, and deliver it affordably and reliably, even during extreme conditions like weather events. So the momentum is building. So in the US, states are stepping up. We're seeing it in California, who's called for up to 6 gigawatts of long-duration energy storage by 2035. New York is offering direct incentives as a part of its 6 gigawatt storage target. Massachusetts, New Jersey, Colorado, state after state are advancing storage goals through tailored standards and programs. So here in Texas, the urgency of balancing reliability, resilience, and affordability is creating fertile ground for innovation, partnership, and leadership. And perhaps the strongest signals aren't just coming from policy alone, they're coming from the market, from energy buyers demanding clean, firm power, from grid operators who are seeking flexibility, and from entrepreneurs who see energy not as a constraint, but as a strategic asset. So we're entering an era, my Taylor Swifties, my era, of infrastructure with intent. So where we don't just build to meet demand, but we help shape the future. Long-duration energy storage is central to that transformation. So unlocking its full potential is going to take more than just technology. It's going to require long-term confidence, the kind that turns pilot projects into industry platforms and sparks durable investment in communities and supply chains. So that's why today's milestone matters. Because when energy storage is part of the original blueprint, not an afterthought, not a bolt-on, it accelerates everything: local job creation, grid reliability, and broader clean energy transition. So this region and LDES Council member TerraFlow are showing what's possible when infrastructure, manufacturing, and energy innovation converge. And the convergence isn't just a Texas story, it's a model for the country. So a few thoughts to leave you with. The need is clear, the technologies are ready, and the boldest projects, the ones that plan for flexibility, design for resilience, and build for purpose, and with purpose, will lead the next chapter of the American energy leadership. So on behalf of the Long Duration Energy Storage Council and our global members, we're proud to support this progress and excited for what comes next. Thank you very much.
Wow, we've heard all the technology, we've heard the policies that make this work, and now let's talk about where it's already happening and where it's about to happen on a scale that actually changes the game. So I'd like, please welcome back John Perella.
This button. We're going to talk about what we're doing, where we've been, where we're going, how we're going to get there. Right now, we're here in Texas. We want American-made. We want to stand up manufacturing. And fortunately for us, the first few projects, the announcements we're about to make tonight, are here in our home state. Cheyenne, one of our balance of plant engineers, this is where we started. This is a Keynote Energy. This is our Sandbox 1. And this was an announcement we made. What's amazing is this is actually at the pneumatics and hydraulics facility where we were able to prove within a very short amount of time with the right partners that we could build the balance of plant to make a flow battery work. Okay? Keynote didn't even believe we could do it that fast, but one of the reasons that we love having all the partners that you got to hear, and unfortunately we couldn't have all of our partners up here, that's just some of our partners, it gives us flexibility. To be able to scale at the size we're about to show you here in a minute, it takes an army, and it takes capital, and it takes influence and politics and everything else. And fortunately, we haven't had a bad meeting yet. We're in the right place, at the right time, right political environment. Everything seems to be aligning. SB 6 came out, Senate Bill 6 came out, and it was like, holy cow, they just basically forced everybody to buy our batteries. That worked in our favor. Keynote is a strategic partner for us, and we entered into a supply agreement with Keynote because of the fact that we do believe that we need to be able to have variety in our source to make sure that we can deliver at the scale we're talking about. So Keynote is actually an organic version, and our IP is not in the chemistry, it's not in the stacks. That's why we have multiple suppliers to make sure we have the supply chain to meet that need. But what Keynote did was they gave us an alternate that is cleaner than vanadium, that can use a lot of the same equipment, although we still have some R&D to do with them to design it, but it is a promising future for us to be able to have many different versions of our battery and our IP to solve the problem at the scale that we need to do it and to not run into supply constraints. This is one of the largest organic flow batteries in the United States right now, and it's our prototype. Okay? That was milestone number 1. And we thank Keynote for your support in helping us make that happen, and Voltarion for supplying the organic stack that we're still working with you on to continue to improve. This you saw downstairs. This is Sandbox number 2. And I'm walking you through a little bit of the history, and I'll give you a little bit more excitement about where we're going with the data center technology, because it is really game-changing. We don't see an alternate solution out there that really competes with it, which is why we're experiencing the exponential growth that we're experiencing right now. Sandbox number 2, as you can see, we had 3 days to put it together. And I know that sounds like, it must be easy, anybody can do it. I can promise you it took an army to make that happen. What you see downstairs is nothing short of a miracle that was built in those 3 days, so we could have it here for you to better understand what these things look like, because a picture speaks 1,000 words. This is a testing rig, again, that can test up to 50 kilowatts in scale of different stacks for us to be able to make sure we have enough supply. Storion's a stack manufacturer, Voltarion's a stack manufacturer, Ronke, who's in the room, is a stack manufacturer. We had to go and find supply chain logistics to be able to look at the scale that we're about to talk about. So this, if you want to see it, any one of the people with the TerraFlow logo will be more than proud to walk you through what that actually is if you have any questions about it. But like I said, getting bigger by the minute. This is what we call Frankenskid. This is in Belleville. Belleville, as you saw, for those that saw, we announced a roughly 10 megawatt, 5-hour battery going in. Frankenskid is the first size scale commercially viable product that we're manufacturing with help from pneumatics and hydraulics. They manufactured that big blue, beautiful, called big blue build of a frame out of their metal fabrication shop. So they've been instrumental in helping us to get done quickly. That skid is up to a 1 megawatt scale. It's 40 feet long, 9 feet wide, 10 feet tall. As you can see, you can walk down the middle of it. It's so big. That skid will be energized probably conservatively 60 days, maybe faster than that. But we had to go through and figure out the spaghetti of plumbing, as you saw on the small one downstairs, to be able to get the plumbing to every one of those stacks. Okay? This is a huge milestone for us because this is what we will be manufacturing here in Texas. These 40-foot long skids will be made in our factories, and they will be designed specifically to be able to support grid reliability or data centers. It's agnostic to the use case. They will be 1.25 megawatts in scale, so we are doing very large grid scale. For those that don't understand what that means, a megawatt's about 1,000 residential homes. So we're doing big. And to go big, the design that Ian talked about with large tank format and putting all these skids on stacks on one skid adds a level of complexity that we were able to solve, and that's where our IP lies. It's the implementation of a flow battery in a UPS mode for data centers, and it's the implementation in large tank format that's where we're different. Now, we didn't build them in Connex containers, but they're basically open frame Connex containers, but we did that for manufacturability and for maintenance to keep the cost down. But those now have to be put inside a building. So we had to solve the problem of complete turnkey, where we build the building, the dirt work, the foundation, the tanks, everything that goes along with it. One of our partners in the Recon Construction is our EPC firm that does that. So we vertically integrated not only manufacturing, but construction, software as a service, and operations and maintenance. So we had to solve all the problems. Our background came from operations and regulatory. So we looked at it and said, how does the grid want a battery to operate? Not how do we make a battery? Then we looked at how do we take that battery and make it do that? So we were outside the box thinkers, and that's really where Travis was mentioning and all these other guys were mentioning that we looked at it from a different approach, which is why our battery is nothing like anybody else's. This, if you want to come see it, we welcome you to come visit. Just don't lick your fingers and touch both ends, please. It won't feel fuzzy. But that is in Belleville. It's only 30 miles down the road. We welcome anybody that wants to come see it. We're big believers in putting our money where our mouth is to prove that we can do it. This is what Belleville is going to turn into. So that 1 megawatt skid will move to our new factory here shortly. And this location in Belleville, you can see that very tall building that Matt's going to build for us. We're taking that long building that exists already, and those 40-foot skids will go in there. We'll put 8 of them in that building, and we'll put 4 tanks in the other building. Directly across the street from the Belleville factory, which is where we do mass production metal fabrication today, is a substation. So we're actually building 10 megawatts for 5 hours. Now in ERCOT, if you have less than 10 megawatts, you don't have to go through the interconnection queue, you just have to connect to the local utility. So that process has already started. Permitting packages is already done. Construction on this will start. This will probably be live end of 2026, if not first quarter of 2027. We are moving at pace. This will be the first commercial scale size version of our battery, and we'll have it done probably within the next 12 to 18 months is our goal. We're moving at lightning pace, like they said. That's our goal. It's the only way to get there, because when you see what's coming next, you'll understand why. This is Greenbush. Mr. Jeff Goldberg, who happens to be our landlord everywhere we go, and is also our chief development officer. Strategically, he keeps finding the opportunities before we do. We went to him and said, I got to stand up a small factory to be able to figure this all out. And he goes, well, I happen to have 100,000 square feet I'm building right around the corner in Katy. So we said, great, we'll take it. This looks like a dirt lot. And we flew our drone so you could actually see the status of it. Matt has completed, Matt's doing the construction list again, go figure. But Matt has completed the underground detention in this, and they're about to pour foundations in the next few weeks. This facility that I'm about to show you will be open by the end of this year, if not January. But we're not going to let them go much longer than that because we got to move. The goal of this facility is to stand up 5 20,000 square foot buildings. And one of our first announcements of the night is that we're proud to announce that Storion's actually relocating their entire corporate headquarters on campus with us because they've put that much belief in the story that we're telling you. They're going to stand up their manufacturing of chemistry and stacks and their entire, executive team, engineering team, except for a couple people in Boston that don't want to come down. But they're going to stand up on campus with us so that we can move at a faster pace. Their engineering team has been instrumental in keeping us from making costly mistakes and being able to move at a much faster pace by saying, don't do that. Big no-no. You're going to burn this, or it's acid, it'll create hydrogen, it'll do this, it'll do that. So this facility is going to be instrumental for us. We call it our kind of prototype factory. This factory will actually be capable of manufacturing 2 to 10 megawatts a month of batteries out of 100,000 square feet here in Katy, Texas. This factory will have a lab in it where we'll be able to show off the Franken skid and the first production skid that we'll make. And then this factory, the anchor tenant for this factory will be Belleville. Now we have multiple smaller projects in development right now. So anywhere from 1 to 10 megawatts, they'll come out of this factory. And we actually have the capability of delivering them fairly quickly. This is kind of the second announcement. There'll be more news about it. It's not a formal announcement we're making. But when you look at how do you implement a data center, you have to look at a lot of aspects. And I know Ian touched on it, but maybe his accent didn't make it as obvious as to why this is such a big deal. When you put this battery wrapped around a data center, in line in place of a UPS, which for those that don't know, UPS means uninterruptible power supply. When you put it in as a UPS, where the power is running through the battery all the time, if the grid goes out, no big deal. Data center runs off the battery. We're building it 1-to-1. So if it's a gigawatt data center, you're going to get a gigawatt battery. But what people don't understand, and Ian had the chart up there, is the power volatility of an AI data center is something that none have really seen before. Okay, these data centers, their volatility is a third to half the size of the data center, up to 12, 15 times a minute. When you do the math, the generators and the grid cannot react that quickly. So what happens is, like Ian said, he tripped towns. You create a catastrophic rolling event where it takes out breakers upon breakers upon breakers, and you have a rolling blackout. We know because when we were both formerly at Lancium, it happened at one of the data centers like he mentioned. So the last thing we want to do is expose that volatility to the grid. It does introduce the harmonic distortion, but one of the biggest things now with the Senate Bill 6 that passed, and it's interesting because 10 other states are starting to follow suit, and when we're meeting with Congressman Crenshaw, he says, maybe we should take this up at the federal level as well. And we agree. When you have very large loads and they're trying to move at lightning speed, they don't fully think through the whole process, and every one of them so far has had problems that we've spoken to. And they're all turning to storage to solve the problem. What they're doing is they're taking traditional UPS, they may introduce other long-duration energy storage, but not in a UPS mode, and backup generation, and harmonic distortion filters, and all these other components to be able to solve the problem, which we solve in a much more elegant and simple solution. I have to give credit where credit's due. Ian has done an unbelievable job of going, and it usually happens when he's either driving in a car or he wakes up with an aha moment, but he did an incredible job of figuring out how to design the battery such that it has no switching involved in it. And as he likes to say, the chemistry does not care. This battery doesn't degrade with cycles. It will not catch fire. You do not have to replace anything. It will last 20 to 30 years or more. And at the end of life, it's 100% recyclable. There's not another battery on the planet that can make those claims. So beyond all that, how do you take a data center now and turn it into an asset for the grid instead of a liability? How do you make it such that when the grid needs the power, the data center can be the solution? But wait, that's almost like an oxymoron because the data centers need 5 nines of reliability. They want to be up all the time. Google made an announcement recently in, I think it's Wyoming or one of the Midwest states, where they're solving responsiveness by making the algorithms turn down or turn up. What we've done with long duration uninterruptible power supply, LDUPS is what we trademarked the name of the product. What we've done is we've given the data center the ability to be controllable and or responsive without ever turning off. Now, that chart that you saw that Ian put up there, when you take the 5 peak hours of a day out of the equation, you can cut the power price 60, 70%. And that's just the generation portion. If when the grid goes to read the delivery portion, you're not there because you're running off the battery, your distribution charges almost go to zero. So the savings get very large. Well, the number of data centers being built, there's a rush going on. And that's why there's so much money being spent in the data center world. But what a lot of people don't realize is there's a lot more developers, just like there were with the battery, and just like there is solar and wind, there's a lot more developers than there are tenants. And so if the biggest OpEx cost of operating a data center is power, would you not believe that putting a battery that could lower the cost of power be a competitive advantage for that data center finding a tenant? That's what this does. It provides the ability for you to optimize the price of power while being an asset to the grid when the grid needs it, and still providing 5 nines of reliability and resiliency for that data center to stay up. When they go look for power, what people don't realize is everybody says, oh, there's not enough power to go around for these data centers. There absolutely is today without a tremendous amount of grid infrastructure upgrade. It's just you have to shift when you use the power. Well, that's exactly what a battery does. You charge at night and you run off it during the day, so you're not paying the expensive prices during the day. You're shifting the price of power. So this is a 1 gigawatt data center we are under LOI with. We are in interconnection approval right now in the Houston area, and more news will be coming on this. But just so you understand, a gigawatt is a very large load. And so as a company that's only a year old, to have a gigawatt order already in the works is nothing short of, oh crap, now I got to stand up manufacturing. This is what the data centers will kind of look like. This is an example of one way of doing it where we're wrapping our battery around it with the hull. But you've heard everybody say, wait, these data centers I hear about all these huge campuses. This is our biggest mic drop moment right here. This is the Port of Victoria. And we're actually announcing, in partnership with Optimus Technologies, who's here tonight, and the entire port political infrastructure is here tonight with us. Everything from the chairman of the port to the director of the port to the mayor of the city to you name it, they all came to support us. This is a campus in Victoria, in the Port of Victoria, right across from the port, that is 6 to 8 gigawatts. And Optimus has given us a contract for the first gigawatt of batteries as phase 1 for this project. Each one of those H's that you see, the white H's, is a 500 megawatt haul, which means that every one of those blue things that you see in the battery is 500 megawatts. So this is nothing short of one of the largest campuses for data centers. It is the largest flow battery in the world. A gigawatt is the largest flow battery in the world. This is 6 to 8 gigawatts. So this is going to be a long-term project. It's going to take years to develop. But I just want you to show you that the data centers are starting to have faith in what we've been able to accomplish, to the point where they're saying, I want to use your technology to differentiate what we're doing. So we did it a little bit backwards from most of the other battery manufacturers. You'd be like, well, wait, they all went and got DOE money and they stood up manufacturing first, and they prototyped and they prototyped and they prototyped, but wait, they ran out of money. We went and got the orders first. Now we're going to build the factories, and now we have to move. So part of the reason we're all here today is some of you are partners, some of you are potential investors, some of you are here because you may want one of our batteries for a project. We want all of it. We're hungry, we're aggressive, and we have the means with the team that we've built to be able to accomplish it. This is in the Port of Victoria. This is a proposed site. This is a 3 million square foot manufacturing facility that's capable of manufacturing up to 2 gigawatts of batteries per year. The port is ecstatic with us. We've signed an access agreement with them, which is one of our other announcements tonight, to be able to start exploring and doing the R&D to make this manufacturing facility a reality. We still have some undertaking to go because we're working on incentives and capital to be able to make this happen, but with the faith that Optimus has provided it to us, which Optimus is here tonight, with the faith they provided to us, it gives us creditworthiness to be able to now go borrow the money or raise the money because we have someone that wants to buy the product. Now we've got to stand up the manufacturing. So this is a rough drawing of what the factory could look like. What's also very interesting with all these partners that you got to meet and more that are here is that every time we turn around, the scale of this is much larger than you'd think. So when you build, this is literally across the street from the data center campus that I just showed you. When you build local to the data center campus, what ends up happening is that you significantly reduce the price because you eliminate a lot of the transportation logistics. It's right there. We can walk it across the street. Okay. The biggest component of these flow batteries, as you heard, is chemical. Well, chemical is not easy to transport. One of the unique things about the port that we love so much is that it has barge and rail access. So we actually have a rail spur on campus for manufacturing and barge access to bring things in a much less expensive means. The one slide that I wasn't able to get in here because we were still working on renderings, to facilitate the greater Houston area data center, we actually are looking at even the Katy area to build a 1.5 million square foot factory. So we're actually looking at standing up 2 factories in Texas that equate to over 3.5 million square feet of or 4.5 million square feet of manufacturing that will create thousands of jobs. They'll be AI-driven, automated as much as we possibly can, but you still create thousands of jobs because you still need industrial engineers and electrical engineers and everybody to program the machines to make these things. What we've done is we've figured out the plan to be able to get there. We went and found the customers to help us to justify to get there, and we figured out the unique way of making the technology and spinning the technology that allows us to be able to solve a massive problem with both the grid and the data centers and make it provide an ROI instead of it being just a cost. Our 10-hour battery for data centers in LD UPS is almost the same cost as traditional UPS for 10 minutes. That's where we've been able to drive the price. But the only way to get there is at scale. And so I got asked the question earlier, why are you able to do it now? Why wasn't somebody else able to do it? Right place, right time, right mother-in-law. But the partners that have aligned with us that are rowing in the same direction and that have basically said, we'll give you all of our supply chain. We believe in your model more so than the other ones that we've seen is what's really creating the opportunity. So we're blessed to have you guys all join us today. We really appreciate everybody coming out and being able to share this exciting moment with us. This is just the beginning. You're going to see lots of updates from us, lots of press releases from us. There'll be 3 or 4 dropping today, like I said, with partners co-locating with us. The factories we're going to be built will be campuses of the components because the partners have decided to co-locate with us on these manufacturing facilities, not just make it so that we're making it by ourselves. Everything from transformers to inverter rectifiers to plumbing to metal fabrication, you name it, stacks and chemistry, they all want to be part of what we're doing. And that's creating a very, very exciting opportunity, which I'm holding on for dear life right now and trying to hire like crazy just to help me get it all done. But it's nothing short of having an absolute blast, and it's the biggest opportunity I've been involved in my life. We've been having a lot of representatives help us. You met Representative Crenshaw on Tuesday. We met with Congressman Luttrell, and he looked at it and went, I get it. So part of what we're trying to do today is make sure that everybody understands kind of what we're doing. I know it's not necessarily easy to understand. We're trying not to be just a battery company. We're trying to be a solution company for data centers, large loads, any of those things. The battery can be used in a lot of different ways. There's plenty of other people doing vanadium batteries. That's not unique. It's the implementation of large tank format at the scale that we're doing that's nothing short of a daunting task, but it's something that we thoroughly believe is achievable with the right partners and the right people, which is why we're all here today. I want to thank everybody for coming today. I will turn it back over to Mr. McCoy. There are a number of politicians or their staff in the room. I really appreciate all the support and anything you could do to help us to open doors because there's no shortage of hills that we still have to climb. Mr. McCoy, you're a great MC. I couldn't have done it without you. I thoroughly appreciate you coming and supporting us. Funny story about Don. He's actually the one that introduced us to the Port of Victoria, so we owe him a big steak dinner. But Don wants to put a battery in Fulshire. And Don wants to do that because during the Hurricane Beryl, they lost the water for how long? So when you lose water infrastructure, sewer and water, that's when zombie apocalypse comes out and people just get crazy. So our batteries can do more than just a large loads. We're working with MUDs as well. We've got a number of projects in the queue. And Don, you've been instrumental in helping us get this far as well. So I do want to thank you very much and really give you a round of applause for supporting us today.
Phenomenal, John. And I got to tell you, I was doing a little research that a gigawatt is 1 billion watts. That's pretty amazing. But even more importantly, 1.21 gigawatts is what I need to energize a flux capacitor so that I can go through time. And considering we're in tax season and all that at our city, might be good to go back in time a little bit. But it's an amazing when you think about what we can do with this and the innovation. And I'm so proud to be a Texan and an American, and where freedom can allow us to do these wonderful things. It's amazing. And John, just, the small part of me that just wants to see things happen for the good of everyone is truly what our vision is, and it should be for everybody. But tonight we've seen what can happen when innovation meets action and when a private sector of leadership and public policy work together to tackle challenges in our energy system. Many of you know I'm the president of the Chamber of Commerce, and a lot of people said when I ran for mayor, you can't do both. And some even said it's a conflict of interest. But I said, we got to bridge that gap between industry and government. It's always been so adversarial in nature, and I don't understand why that has to be. So I hope I can change that along with you and you public policy makers. This is the kind of thing we need to embrace that benefits everybody on every socioeconomic scale. So on behalf of the reception is going to go out, like we said, throughout the evening, and we're all accessible to talk to you. But on behalf of TerraFlow Energy, I want to thank you all for being here, supporting the work. Let's keep the conversations going. Networking is the key. And have a great evening, everybody. It's been my honor to be your MC. Thank you all very much.